Hello, how we doing? Okay, so let's try to see if we can't work from first principles. I don't know the answer right off the top of my head. I don't even really have a conception for like what the answer kind of looks like or the method to getting to the answer. But I feel like the first step for somebody like myself would be to just poke around, remembering things like what the definition of these things are. So let me get some paper here. So let me just make sure that my conception of what an arithmetic series agrees with yours. So an arithmetic series is one that's of the form, it's like a function, you can think of it, or arithmetic sequence. Well, I guess it's an arithmetic series here. So we are looking at so maybe I'll start with the definition of an arithmetic sequence first, and then we can define the series. So I would think of this as being like a function. Maybe this is too highfalutin. Just it's a sequence of numbers of the form an plus b, right? Where n, so these are integers, and n is allowed to run through the natural numbers, runs through the natural numbers. Is that the definition of arithmetic sequence that you might have in your head? first in the sequence. So n here starts at 0 instead of 1. That's okay. So I can start these sums here from n equals 0 and not have any issue, right? And then we can have a 3 here in our example. This would be n equals 0. Crikey. Okay, so but can anybody tell me, this is just a good question. If we have the sum from n equals 0 to k of b, is there a nice way of rewriting that sum? Can anybody tell me what that is? Do I use voice? Let's see. I guess we could, let's see. Is it easy to do over Discord? I'm not sure. I've never done voice before. This is my 6th day doing this. So, maybe my 7th day? I can't remember. 6th day, I think is right. Here.
You just want beer? In the store?
Sure. Are you going to the Nugget?
Yeah.
Can you also get me one sec. No, I'm happy to do it. I just am wondering how one really gets this done efficiently. Let me drop a link. I should be doing this anyway, but I'm bad about doing all this kind of stuff. Is to drop the link to the Discord. There it is. And anybody who wants to join, please feel free. You don't have to either. But I think that if we do that, we can join into one of these things. I have a voice channel there, and hopefully it does something. Let me mute my music to make sure that everything's kosher. So can you join, Callum, the voice channel here? Or do I have to shove you into the voice channel? Maybe.
Hello.
Oh, hi, Callum.
Hi, nice to meet you.
Nice to meet you. Yeah.
Yeah, so I just thought it might be easier if I came on voice and spoke to you. Can you hear me okay and everything?
I can hear you wonderfully. Can you hear me okay?
I can, yeah, definitely.
Great. And I'm wondering if folks on stream can hear as well. Could be useful to... Hey, can folks on stream give me a thumbs up or thumbs down on both of our voices? So right now we're talking about arithmetic series, which are just sums of arithmetic sequences, I believe. You can't hear them.
Yeah.
You can hear me, though. Huh. What is up with that?
I can hear myself on your stream. It might be just because I haven't spoke before.
Strange. If I turn you way up, does this work? Not the other guy, though. Okay. Why is that?
Oh,
Could you hear...
just
Just out of curiosity, could you all hear the music that was playing earlier? There's always a... No, you couldn't. Oh, interesting. What does this imply? So, let's see. Properties. How... Properties.
Hello?
These are things that I should have at some point work out, right? This would be a very useful thing to have working, but
Um, I'm
but
not
for
sure what
now,
you.
I mean I don't want to keep you waiting around.
It's all right. I've got ages. It's like 9 o'clock in the UK. I'm not sure where you're from yourself, but
I'm in the States. I'm in California, so the West Coast. So right now it's 1:21 p.m. just afternoon for me. Oh, you can hear them now. What? How did this happen?
seems we've fixed it.
Okay, can you hear them cleanly? Like clearly? Okay, I have no idea how that happened, but we're gonna go with it. And yeah, wonderful. So tell me how I can fix this notation. So I've defined the arithmetic sequence as an plus b. Pretty sure you're using different letters.
It probably is because obviously I'm learning from like the UK syllabus. It's like a British qualification, so I know there's a lot of differences between the two. But that formula up there is the one I've been given. It's written down correctly.
Mm-hmm.
But essentially, I've just touched on looking at the sigma, and it's basically it does make sense how you've done it. I think you are just using different letters, but the way I have it is A is the first. It's like the first number in the sequence, if you get me.
Yep, I
Obviously,
do.
they're supposed to be all summed, and then D is the difference between two of the numbers,
Great.
like two of the consecutive numbers, if you get me.
I do. Yeah. So in
And
general,
N
oh, go ahead.
is based like N is like the same as K, sort of.
N is the same as K, right? Okay. The number of terms of the sequence or something like that, right?
Yeah,
Yeah.
yeah.
Okay. So under these with these A's with these choices of letters, I would say that probably what we're working with here is I'm going to use a different even letter for what I usually call the index. I'm going to make that be, I don't know, I. So the arithmetic sequence that we're working with here is D times I plus A, where I think starts at 0 and then goes through the positive integers. Are you comfortable with that, or does that make
Um,
you nervous?
yeah, we can do it like that. Go over it again. So, which one have you changed? So, what's the I again?
So I'm using I here because I want to avoid using N. It seems like in this formula, N is representing the number of the terms of the sequence that I want to use. In other words, I just want to avoid using N for now, and I'll
Yeah,
put it in later.
yeah. Okay. So, all N is it that I understand is it's just like the up to the term that you want to sum up until.
Yeah,
So,
exactly.
say you want, yeah.
I have to be a little bit careful though, because if I'm told, as you are in the problem, if I'm told the sum of the first 20 terms, there's a what is sometimes called a fence post problem because I'm including 0 as one of my indices. But that's not
Yeah,
we can think about that later. But so if we think about this arithmetic sequence, we go term by term. The first term will be A, which is exactly what we want here. The first term of the sequence is A. The next term would be A plus D. Next term would be A plus 2D, etc. Does that make sense?
yeah.
Okay, cool.
That's like you learn. That's the same formula that you learn just before this. So we do that as well. The other formula I gave you is just one to sum them, if you get me.
I totally get you. Absolutely. Yeah. So this is the sequence itself. And then to get the sum, which I suppose you're calling S, what you do is you do the way that I would typically notate this, the way that I typically write this down is to use this sigma notation thing. So I would say that the sum would be the sigma thing from I starting at 0 going up to whatever number you want. And I guess we're going to take here, I'm going to put an n up there. So what this means is that it moves through the values, the positive integers, or rather the integers, starting at 0 and then clicking through the integers until you hit n. And when you hit n, you include that term, but then the process stops.
Yeah.
So if I write then di plus a or whatever, or a plus di, maybe I'll write it like that in this order. It feels more aesthetically pleasing to do it that way. Then the number of terms in the sequence that I'm summing up, this is the sum of n plus 1 terms of the arithmetic sequence. And the reason why there's that annoying 1 there is because
it has an offset.
Yeah, because we started I at 0, right? Instead of starting I at 1. Thank you for the follow.
Am I right in thinking that's what your so that's what the n minus 1 and that's the formula I gave above is to do, sort of?
Okay, so this n is this n intended to be the sum of the first n terms? That's what you want it to be?
So it sums up until n number of terms.
Okay, yeah, so it's the sum of the first n terms of this sequence here.
Yeah.
Yeah, so this is a little bit different. So if we want to get it on the nose, if we want these two things to agree, then what I should do is instead put an n minus 1 up here, right? So that this becomes the sum of not the first n plus 1 terms, but just the sum of the first n terms. And I can deal with that. So now the question is, I think, how can we make this and that look the same? These two things look the same. So this requires some understanding of what this sigma business, this is the capital Greek letter sigma. This requires some understanding of how one manipulates sigma notation to get from a formula that looks like this to something that looks like that. And that's what I want to explain. If you're amenable to that.
Yeah, definitely.
Okay, so the first trick is that because this sigma notation is just a glorified sum symbol, it means just taking a sum repeatedly, we can break up this expression here into two pieces. We can break it up into the sum from I equals 0 to n minus 1 of just a plus the sum from I equals 0 to n minus 1 of di. Are you comfortable with that step?
Yeah.
Okay, cool. Yeah, and that's because if we're going to be adding up things of the form a plus di, another way of doing that is just to add up the stuff that just to add up the a's, and then after that, add up the di's, and then add the two quantities that we get together, those two sums together. And that's essentially what we're saying here, right?
Yeah, that makes sense.
Okay. Now, the first part here is this sum here. Sum from I equals 0 to n minus 1 of a. Can anybody think of a way of simplifying that to get rid of, in particular, the summation symbol? Like let's say we wanted to get rid of the summation symbol, not write it using a sum, a sigma rather. How could we do that? One second, I'm just going to close my door. So let me give you some indication of what's happening here. So like, let's say we were to do the sum from, and I'm going to use I starting at 1, I don't know why, and we go up to 3 of, let's say, the number 5. We could write down a expression like this. And what would this mean? This would mean that, so I starts out at 1, and then we are going to add to that first term 5, which is this. Sorry, so how can I say this? When I is 1, the value of this expression that we're summing up is, of course, 5. So this 5 right here corresponds to I equal to 1. Then we click this I to the next positive integer. And that happens to be I equal to 2. Now, what's the value of this expression when I is 2? Well, it's again 5, right? So this is I equal to 2.
Yeah, because there's no actual multiplier in there. So is it just A then? Is it?
Well, so let's be careful. What's playing the role of A in this example? In this formula, in this sum here, what's playing the role of A is 5, right?
Mm-hmm.
And we notice, I hope that you notice, that the value of this sum here is 5 plus 5 plus 5. In other words, we're adding up 3 copies of 5, right? This is 15.
Oh, yeah.
Yeah?
So then could it not just simplify to n times A?
Yeah, exactly. Because
A.
how many times, exactly right. Because how many times are we adding A to itself? We're doing it n times. And I know that that might be mysterious to some people because you see the n minus 1 up here. But remember, we're starting the index here from 0. So in fact, there are n A's that are being added up together, which of course is equal to n times A. Okay,
Yeah.
cool.
Oh, it's because yeah, no, I get it. That makes sense. I was
Great.
just confusing myself, thinking it would just stay the same because obviously you're summing it each time, aren't you? So
Yes, you're summing it each time. Exactly right. And now the next piece here, this other piece, requires a little bit more delicate argumentation, but it's fun. I insist that it's fun. So let's take a look. What we're going to do with this, notice that this D, okay, it does not depend on I at all. D is just some dumb number, right? It's the difference between 2 subsequent terms in the arithmetic sequence. So
it's a constant.
it's a constant. And so because it's a factor of every single term in this sum right here, in this entire sum, we can factor it out, right? In exactly the same way, like if we had 2 plus 4 plus 6, we know that 2 is a common factor of each of these summands, so we can factor it out. This is the same as writing this, right? So we can play that same game here, and this D can come outside the sum, and we get D times the sum from I equals 0 to n minus 1 of I. So now the big question is there a nice way to simplify this sum right there? Yeah, some people know it. I can see in the chat. But I want to give you an argument, a really cool argument for this. So let me just sort of put this up here and get a new piece of paper because I'm going to want to draw a picture here.
Sorry, what was I again? What was I? Sorry.
Good. So I is just this index of what's sometimes called an index of summation. So I is the thing, remember, that's clicking through the positive integers until we hit n minus 1. It starts at 0 and goes up to n minus 1.
Number, is it?
I'm sorry, say again?
So it's just the number of term in the sequence.
Yeah, the index of the term. So like let me write this out. It's a very concrete thing. If I write out I equals 1, the sum from I equals 0 to n minus 1, it's a very concrete thing of I. So when I starts out at 0, so that's going to be our first summand is what we get when we stick I equals 0 into this expression, into the thing that we're summing up. And of course, when I is 0, so that's not very mysterious. That's just 0. The next term will be when I is 1, and of course that's 1. The next term is when I is 2, and of course that's 2. And what we have to imagine is that this continues until we hit n minus 1.
Yeah.
Yeah. So now the question is there a nice way of rewriting the sum of 0 plus 1 plus 2 plus 3 plus ... all the way up to n minus 1? And I claim that there's a really lovely way of doing that. So here's how we can think about it. Let's ignore the 0. 0 doesn't contribute anything to the sum, right? So we can ignore that. But what we can't ignore are all these positive terms here. So the way that I'm going to draw a picture of this sum. So for 1, I'm going to draw a single dot. Okay. For 2, I'm going to draw 2 dots. Now, if I wanted to sum 1 plus 2, of course, what you know from elementary school is you can just count the number of dots, right? There's 3 of them there, and 1 plus 2 is 3. I'm going to do the next term too. 3. Here's 3 of them. Here's 4 of them. And we're going to keep going like this, and I'm going to stop because it seems pointless to do this. I'm going to stop at 5, but we're going to pretend that this last row here, this last row is n minus 1 dots, like right here. This is n minus 1 dots, right? And similarly, this is n minus 1 like rows, right? This is the first row, this is the second row, this is the third row, and this is the n minus first row. Is that clear?
Mm-hmm.
Cool. And now what I'm going to do is I'm going to draw the same picture, okay? I'm going to draw the same picture, but I'm going to draw it in red. So I'm going to draw now 1 dot. There's 1 dot. Can you see the difference between the red and the black? Here's 2 dots. So here's 3 dots. 1, 2, 3. Here's 4 dots. And then here is n minus 1 dots.
Yeah.
And you can see that what I have here is a rectangle of dots, right?
Mm-hmm.
Now and furthermore, the value of this sum is equal to the number of black dots here. We agree?
Mm-hmm.
Not the number of dots altogether. If I was to take the number of dots altogether, that would be twice the value of this sum. So if I call this sum, what's a good name for it? What's a good name for this sum here? Let's just call it, I don't know, T. I just picked that letter because I didn't want to use S. We already used S somewhere else. Then I think we can agree 2T is equal to the number of dots in this rectangle.
Yeah.
The height of this rectangle is n minus 1, right? There are n minus 1 sort of rows of dots here in this rectangle. And how many columns of dots are there?
It makes sense, but I can see in the chat how it's been done, but I don't understand because it's where does the d come into it? Why is the divided by 2 multiplied by d?
I think Kramer is anticipating what we're going to be doing very soon, but I think what he or she wrote there is something like the formula that we're going to develop for t. So I'll ask you. I'm going to ask you. Just follow along with me. I swear to God, I'm taking you on the path to developing this formula in a very intuitive way. So this is a rectangle worth of dots here. There's n minus 1 rows of dots. How many columns of dots are there? So what we go ahead.
N minus 1 plus 1, so just n, is it?
Exactly right. There are n dots total, the n columns of dots here. So how many dots are in this rectangle?
N squared. It's n times, n squared, is it?
Almost. So remember, how many rows are there? There's n minus 1 rows.
Minus 1n, is it? You multiply n and then divide it by 2.
To get, so 2t, the number of dots total in this rectangle. So this is the number of dots. This is going to be n minus 1 times n, right?
So is it n squared minus 1n divided by 2?
Yes, exactly. So t is n minus, as you say, n squared minus n over 2. Exactly. In other words, this complicated sum here is equally well written as n squared minus n over 2.
I think I've actually seen what your I think I've actually seen that formula before, but I'm not sure. I haven't touched on that yet. For the
Okay, see, well, so it seems like it's absolutely necessary for solving this problem to know this formula, or to have some way of coming up with it. That's the way it feels to me,
Yeah,
honestly.
yeah, I saw that when I was because I was searching for answers to this problem, and I'm sure I've seen that formula, but I definitely haven't touched on it in this book yet.
Okay, wild. So maybe,
But
my guess is that what they're doing when they give you a formula like this one is that they're sort of withholding from you the derivation of this formula.
yeah,
Yeah, and I believe, and I could be wrong, but I believe that the way that this formula is derived is from this sort. One of the necessary steps along that derivation will be to understand what this sum looks like. And the fact that it's n squared minus n over 2 goes a long way to actually developing this formula.
yeah. I think it did touch on it briefly at the start of the thing, but it just says it puts it in a way where I'll just see if I can find where it said it. Sorry, 1 second. I can't find it, but I think it was just. I think yeah, actually, it has covered this sort of, but I think it's quite different the way it does it.
Oh,
It's
okay.
just all it does is it lists all the terms heading upwards and then it puts them downwards, adds them together, and then it becomes 2s or whatever it must be, and then obviously all of them equal to the same thing. It's quite. It'd make more sense if I could find it. I can't remember it exactly.
Ooh,
I'll just be a second.
I
Yeah,
think
so it says let s 1 plus 2 plus 3 running up to 100, and then it reverses the sum, so s
reverses
equals
it.
100.
Yeah.
Yeah, and
Yeah,
it adds them together.
right. So that's honestly kind of like a sort of more I don't know, equation based way of going about doing what I've done here. Because
Yeah,
it's sort of like, here's the 1 and then here's the 5 that you get from the sort of reversed, doing it in the reverse order, right? And you're putting
yeah,
all of those in a row. And then you're doing the same with 2 and 4, 3 and 3, 4 and 2, 5 and 1, etc. So it's just I think what this
it's a
is that,
different way.
yeah, it's just a
Yeah,
different presentation of exactly the same thing. Yeah. So anyway, if we go back to here, right, and we're trying to develop this formula, then S is equal to NA plus D times, now we know the value of this sum here. This sum is equal to n squared minus n over 2. Okay, so now we can try to figure out how we can manipulate this expression to get the S up there.
just really quick for the guys in chat. The book says it was Gauss. So boring Professor Servant, you were right on that one.
Yeah, Gauss, there's like a legend. This is the legend of this kind of problem, that Gauss, when he was in kindergarten or something,
Yeah.
was, I don't know, acting up in class. And so the school teacher told Gauss, like, go in the corner, take a chalkboard, and add up all the positive integers from 1 to 100, thinking that this would be some kind of time-consuming punishment for Gauss. But what she didn't know is that Gauss was able to come up with the answer, which I think is 5,050, more or less instantly, because he was able to sort of work out a little scheme like the one we're talking about right now.
Yeah, that was the one. Yeah.
Yeah.
It does tell you a bit about that at the start of the chapter.
Right.
It's interesting.
Okay, so we have this guy here. Let's see if we can make it look like the formula that you gave me, just to make sure everything's on the up and up. Seems to me like there's a common factor of n in both of these terms. Do you agree?
Yeah.
Yeah. So this looks like n times a plus d times, let's see, if we factor out an n from here, it looks like n minus 1 over 2 to me. Now, I see an n over 2 in front of the formula you've been given. How can we see an n over 2 in this formula? We have an n out front. Can we see an n over 2? Well, sure. What we can do is multiply this piece here inside the brackets by 2 and compensate by dividing this n here by 2, or multiplying by 1/2. So this is the same as n over 2 times, now I'm going to multiply this thing by 2 to get 2a plus d times n minus 1, which is exactly the same thing as what you gave me.
Yeah.
Yeah. Cool. Like these two things are, yeah, exactly the same. All right. Now let's actually solve the problem that you asked, because I know that this was a little detour, but I wanted to do it just to make sure we were on the same page with notation and all that.
Oh, yeah, that makes perfect sense. Yeah.
Great. So your thing was, remind me what it was. So the sum of the first three terms
was equal to 12. Let me just find it so I'm not giving you the wrong numbers. Where was it? As the sum of the first three numbers of an arithmetic sequence series is 12. So n 1 to 3 equals 12. If the 20th term is minus 32, find the first term and the common difference. So it wants to find A and D.
Okay. So if the sum of the first three terms is 12, then presumably we could take this equation here and set it equal to 12 if we plug in the correct value for n. Now we need to be careful here. What is the correct value of n that we're going to want to plug in?
Is it? I'm not sure. Do you mean, so if you set that equal to 12, but you don't know what n is in that case, do you? Because,
well, so you do. And the reason is because this is supposed to be the sum of the first three terms, right?
Yeah.
So we're going to take this equation, the one that you gave me, and we're going to set s on the left. We're going to make that be 12, because this is supposed to represent the sum of the first n terms of the arithmetic sequence. So what is the value of n that I should be plugging in on the right?
Oh, I think I understand why I've confused myself, actually, because it's this. Because this, because 12 actually is already the sum. I was thinking of we needed to find the three different sums. So we needed to find the first three terms. I think that's how I've confused myself with this question.
Oh, I see. Okay.
I'm not sure if I'm confusing yourself now, but yeah.
No. This I feel like this is going to work out. And the reason I feel like this will work out is because these two pieces of data, one of the first one should be that 12 is equal to what? 3/2 times 2a plus n here is 3, so we get a 2d, right? So this gives us an equation in a and d. Now, this alone does not tell us what a and d are, but because we have a second equation, namely that negative 32 is equal to, let's see, when n is 20, we put 20 over 2 times 2a plus 19d. The fact that we have these two equations that both simultaneously must hold for the a and d that we're interested in means that we should be able to solve it. In general, when you have two equations with two unknowns, or k equations with k unknowns, particularly when they are linear equations, in general, typically you can solve that uniquely. So you should be able
So
to find an A and D which work out here.
so are you going to simplify it and then rearrange it so it equals like 2a, for example, and then substitute it into the other equation?
Sure. So like if we just walk through, so this is it's sometimes called the system of equations. If we there's so many different ways of solving a system of equations, but I think the path that you suggest here is a good one. What I would encourage you to do here is to, for example, distribute the 3 halves. And if you do that, you get 12 is equal to 3a plus 3d. Do you see that?
Yeah.
And then you can divide by 3. So you learn that a plus d is equal to 4, right?
Yeah.
And then, if you like, what you can do is solve this equation for one of the variables or the other. So I'm just going to more or less arbitrarily decide to solve for a. A then is 4 minus d, right?
Mm-hmm.
Oh,
Just
so somebody is asking for clarification. They say, correct me if I'm wrong, but I think the question states that the 20th term is negative 32, not the sum of the 20 terms. Did I hear wrong?
Oh no! Oh yes! Oh yeah! It is. It's if it says if the 20th term is negative 32.
Oh, so the 20th term, that's very different. Okay. So but I am right that the sum of the first 3 is 12, right?
Yeah, the sum of the first 3 numbers is 12.
Now the 20th term is equal to negative 32. Okay. So that gives us a different equation, right? This is not the right equation anymore. This second equation, right?
Yeah, I think that's where I've been going wrong because I was doing the exact same thing as you there by substituting it in, but I think I've confused myself with the way the question's been worded and just done it incorrectly that way.
Yeah, sure. So the first equation here comes from the sum information, the sum of the first 3 terms, right? That's where this first equation comes from. But this second fact about the 20th term being negative 32 is going to generate a wholly different equation. And our job is to figure out what that equation is. Do you have
Yeah,
any inkling, any idea of how to get an equation out of this statement?
So 1 second. So I'd think it'd be one moment.
Hey, 2 char, 3 char, thank you.
Strip it back to set it as with A and D,
Yeah, I agree.
and set it to minus 32 equals A plus N times D.
And what's n here? If we're talking about the 20th term.
So N is 20.
Are you sure?
I don't know if that's right. I'll put it as negative 32 equals A plus plus 20 times D.
So the first thing that you said was that it was going to be negative 32 is going to be a plus n d. And my question was, what's n if we're talking about the 20th term? So in other words, is the nth term of the sequence the same as a plus nd, or is that equal to a plus nd?
100%. I was just thinking. I was just thinking, as in n is equal to 20 is the information that you've been given, or do you mean maybe it's
Well, so let's be very precise
you
here.
set it as -1, so it's 19?
Exactly.
Yeah,
Yeah, the n here is 19, and the reason for that is because way back here in our derivation, we started I at 0. So the
yeah,
first term, the n equal to 1 term will correspond to I equaling 0.
yeah,
The n equal to the second term will correspond to I equal to 1. The third term will correspond to I equal to 2, etc. And so the 20th term will correspond to I equal to 19. So this is actually A plus 19D.
yeah,
Okay. So we still have legit. So we took this first. So we have now a system of two equations corrected because now we've interpreted the problem correctly and I've heard it right and all that. I have to work on my listening. But we now have this equation here and that equation there. And this still represents a simultaneous a system of equations. Sorry, a system of equations that we should be able to solve for A and D. Now we massaged the first equation to learn a very important fact that A and D are related in this way: that A is always 4 minus D, whatever D is.
yeah.
So
So
now
you can just insert that and then solve for D.
now what we can do is take this and plug it in to this equation. Does that make sense?
Yeah.
Cool. So
This
then,
is this. That's what I mean when I say substitution. Is you're substituting A for the 4 minus D.
beautiful. You're absolutely correct. Yes. And from there, it should be child's play to figure out what
Yeah,
D is, right?
yeah.
And
So you
then
just
once you
solve
know,
for D.
yeah,
You
solve for
just
D.
plug it back into 4 minus D to get A.
Exactly. And then once you have
Yeah,
A and D, those questions that you're asked, again, easy, right?
yeah. Thank you very much for your help with that. I think what I've done now is I've just confused myself with the way it's worded
Yeah.
instead of because I think because I was trying to so I was thinking to try and put like so 12 equals the first term plus the second term plus the third term and then substituting that in and trying to work out the individual terms by
Hmm.
substituting that in, which obviously it can never work because you're always left with two different variables each
Mm-hmm.
time you substitute it. So
Sure.
I was stuck on that one for quite a while, but thank you very much for help with that. I do really appreciate it.
Yeah, of course. Anytime. I really appreciate the question. Yeah, and good luck on your whatever exam you're studying for. What is it again?
So in the UK, so I just sort of didn't really do much in school. I just sort of had a laugh and didn't really try. So in the UK, you can do a qualification, which is like an access to higher education.
Oh, okay.
So I've done one of them, which allows you to go to a university or what you might call a college.
Yeah.
Um, Obviously, on that course, it does all the most important things over the course of 1 year to get you ready to go to university.
Mm-hmm.
But obviously now I'm going to now I've completed that course and I did quite well in it. I'm going to study at one of the universities in the UK to study mechanical engineering.
Oh, that's
So
fantastic.
I'm literally trying to cover everything I can before I start, so I'm not left behind. If you get me.
I get you completely. That sounds like quite a project, but one that I hope pays off for you in the long run for sure.
Yeah. So I mean, I have touched on some of the things, but I've never actually touched on sequences. So this is my first time doing it, but after this, I've got differentiation and integration, and then a few more bits in another book.
Oh,
I should be
excellent.
ready.
Yeah, and if you ever have any questions, I know you're learning on your own. There's lots of places. I hope that you'll count this channel as one of those places where you can get some insight and answers. You know what I mean?
Yeah, definitely.
Cool.
I mean,
Awesome.
I've been trying to Google stuff and that, but I heard about you on Reddit.
Oh, good.
I'm not sure where it was posted, but I seen someone post it, and then I thought I'll have a look. And I got the notification that you went live, and I thought, oh, I can't find an answer to this question anywhere. I'll come and ask and see what it
Yeah, that's
see
great.
what you thought. But yeah, definitely. I
That's
will.
great.
I imagine you'll see me back. I've got a lot of work to do before I start. So
Yeah, yeah, and happy to have you. Thanks for the great question.
lovely. Great. Thank you very much,
All
and
right.
best of luck.
Thank you very much. You too. Bye.
Bye bye.
Well, that was cool. Hey, if anybody else has a math question, or anyone has a math question, why not try and chat? As a mechanical engineer, spend most of your time on calculus. I had a curious question above. LOL, I don't know if you're up to the challenge. I don't know either. How can I know until I see it, right? But give it a shot. I'm more than happy to look at it. And if I don't know anything, I'm not going to try to mislead you or anything like that. I'm just going to say, I don't know what that means or how to solve that or whatever. Yeah. But that was fun. So, how did it sound on your end, Twitch chat? Did it sound okay? Both me and Callum's voice? Audio was good. Great. Very good. Very good. Yeah, so for those that don't know, or if you're new here or whatever, uh, the aim of this channel is to become a place where one can give and one can get mathematical knowledge, mathematics. So I don't mind if you're a giver or a getter or whatever. Either way, you're welcome here. I don't care if you are a you have a PhD in mathematics or whether you're in junior high school or elementary school. It's all okay. And if you are curious about something or you have some question or something that confuses you, you can just drop it in chat. Or, if you like, we can talk over Discord like we were just doing, like I was just doing with Callum. That's sort of what I'm hoping this place becomes eventually. Maybe instead of music, what I'll do in the downtime. Sure, just if you want to just ask questions in chat, that works great. Oh, the chi-square is in statistics. It's been a while. It's a kind of distribution, right? Well, I definitely don't know it off the top, Asia. Yeah, I'm not gonna try. I feel like this is stuff that I learned once a long, long time ago. So I'm gonna just plead that way. But maybe somebody else in chat knows about the chi-square stuff. Yeah, the Poisson distribution. I'm more familiar with that for sure. Yeah, the exponential distribution. Yeah. Consider the point xy lying on the graph of the line blah blah blah. Let L be the distance of the point xy to the origin. Write L as a function of x. I've been stuck on this homework question. Okay, so do you know? Okay, so I think some ingredients which you absolutely need to know. One of the ingredients certainly is the distance form. So wait, let's take a broader view maybe of this question. We have in the plane some line. Now I'm not going to bother to plot carefully the line that you're describing there, but I'm just going to sort of maybe pretend a little bit that it looks something like that. Okay. I'm going to pretend that this is 6x plus 7y equals 5. Now, I know it probably doesn't look like that, but, close enough, whatever. And there's x axis and there's y axis. And then the idea is that for every value of x along the x-axis, you have a corresponding point on the line. And this is because, and this will be true about any line which isn't vertical, right? As long as it's a non-vertical line, you're going to have a correspondence between points on the x-axis and points on the line, a very clear correspondence. And in fact, this equation here really gives you good information for how that works. And the question that is being asked is what the distance of a point on that line corresponding to that value of x, what the distance is between that point and the origin, 0, 0. And we want this as a function of x only, right? Well, on the other, so we want it as a function of x only. Oh, and I'm sorry, you called it L. L. I'm like butchering people's notation today. There's L. You would like to know what L is as a function of x. So a key ingredient, and let me see if you know this, Kurama. The key ingredient here, of course, well, I don't know, of course, but it's something called the distance formula. Are you familiar with it? Formula. It's called the distance formula. Something happens when you're on stream. I can't quite explain, in which it's like your ability to write is like severely degraded. I don't know what it is. I think it has to do with a similar kind of thing that happens when you're taking oral exams, where it's like your IQ or your IQ drops by like 20 points or something like that. I've been trying to use the formula to answer it, but haven't been doing well. Okay, so the distance formula, let's say, so between 2 points, so the distance between 2 points, let's say that they are given by x1, y1, and x2, y2. I mean, I'm sure you know this. This is, the distance is the square root of we can do either way. I'll just do x1 minus x2 squared plus y1 minus y2 squared. Oh, you've been messing up maybe on the algebra stuff? Okay, that's fair. So then it's clear one of the points that we care about in plugging into this distance formula thing is the origin, which is 0, 0, right? And that's lovely. 0, 0's super easy to work with and all that. Can you tell me what you were using as the coordinates of this point here, Karama? It might be messy to write in chat. I don't know. But maybe you can tell me. What is the coordinate, or what is the sort of, what were you writing down for the coordinate of this point which lies on the line that corresponds to this value of x? Cool, cool. I think this heat is a little bit too intense of music for a stream like this. So I'm going to put something which is a little bit more, I don't know, a little less distracting. We'll go with this. Oops. So you had negative 6. So good. So what you did, I don't know if that's exactly right, but let's take a look. So I can see what you intended to do. What your intention was to solve this equation here for y, and I think that's a really good instinct. So we can subtract 6x from both sides of the equation and then divide by 7. So we get 1/7 5 minus 6x, right? And then what we're going to do is make the coordinates of this point here be x comma 1/7 5 minus 6x. Good pickup lines. Wow, I'm totally the wrong person for that. But I'm smart. Well, thanks for saying that. I don't think I'm smart in that way, though. Gonna be honest. Why don't you be the numerator and I'll be the denominator, and both of us reduce to the simplest form? Wait, so Karama, are you serious about that 9? You seem pretty focused on the 9 thing. Did you see what I did here? I took 6x plus 7y equals, was it, you wrote 5, right? Let me just make sure. Yeah. So this was the equation for the line that you gave me, 6x plus 7y equals 5. And what I did was solve it for y in this manner. Is it clear how I did that? And it feels like it's clear why I did that to you, but is it clear that this is the correct? Yeah, no problem. So then L of x, it's just like you said, this L of x thing is going to be the distance between this point and 0, 0. So that's going to be the square root of, we can do the x coordinates, which is 0 minus x, or just x minus 0. We can do it either way. So we have x squared plus this thing squared. 1/7 times 5 minus 6x. This whole thing here is squared. I really wonder how successful math related pickup lines would be. I'm highly skeptical. But actually, it's kind of interesting. Because if you use a math pickup line, aren't you sort of kind of filtering a little bit? There's a filtering process there where, you're looking at you're sort of selecting for those people that would respond well to that pickup line. So though you may be rejected a lot, because let's face it, being into math, and enjoying math is a fairly rare trait, unfortunately. You might just figure out just who those gems out there, just who those gems, you can figure out who they are through a math pickup line. The nerds, you figure out who they are. Oh, could this be simplified? I suppose so. It's kind of gross looking right now. I don't know that it's going to get much nicer, but I understand that sometimes people like non-gross looking things. I agree with you, Callum. But the reality is, particularly, I mean, I can't speak for everybody, for all of humanity or anything like that, but in my experience in the United States, math education is, well, it's piss poor, but and it could use a lot of improvement. Let's see what we can do with this. So there's 1/49th there, and then this becomes 5 minus 6x itself squared, right? Because exponents distribute over products. And then we could write this as x squared plus 1/49 times 25, oh my, minus 6x, so minus 60x plus 36x squared. I really don't think this is getting any nicer, if I'm going to be honest with you. Hey, 2char3char underscore, thank you for the follow. Feels weird to do that, if I'm going to be honest. I'm just a normal person, but now I'm streaming, so I feel obligated to give you all shout outs when you follow, one of those things. I think it's poor because all of maths is all built on the basics, and in the UK, children are taught the basics by teachers who have never actually studied mathematics at a reasonable level. Very similar state of affairs here in the United States. There are just too many anecdotes, sad anecdotes, and even from my own personal experience, I know. But there's too many sad anecdotes that are out there about, high school level teachers or elementary school, middle school, elementary school level teachers who just teach math kind of badly. And though they mean well, the the strictures of their job make it very, very difficult for them to really do well. One sec. So, hey, I'm going to take off now. It's almost 3 a.m. from where I'm from. Do I have a schedule? Is this a daily stream? So, I have been streaming every day for the last 6 days. I plan on trying to keep up that kind of schedule. I typically stream, and you can use this as some kind of metric. I typically stream from 1 p.m. Pacific time being like where California, the west coast of the United States is, till maybe around 5, taking a break for dinner. So, for example, that's what I did yesterday. But on Sundays, I kind of feel like there's going to be a lot of people floating around Twitch with math questions and such. So I might also do an evening stream. I'm planning on doing an evening stream tonight from like 7 p.m. Pacific to, I don't know, 10, maybe 11. But, and I can try to come up with a schedule, but, and I know that would be beneficial for people. But I haven't fully decided or committed to like a really strict schedule yet, if I'm going to be honest. I'm currently in Calc 1 in college, and I'm just realizing that my poor high school education is really hindering me in college math. Yeah, you know what? Sounds good. It's later 2 char, 3 char. Thanks for stopping by. You know what, Karama? I'm gonna give you the straight dope here. Okay, in Calc 1, the thing I would say, the variable which has the biggest impact on whether or not a freshman in college, let's say, comes into Calc 1 and passes it or not. The thing that would give me the most confidence that a Calc 1 student will pass is their algebra skills. It's not close. A lot of the ideas in Calc 1, though they are new, are not so difficult to sort of interface with, to like use and understand if your algebra skills are super on point. So my advice to anybody going into Calc 1 who's nervous or wanting to prepare for the calculus sequence is like, get good at algebra. It's super, super important. Yeah, FS Rooster says, I often see students oversimplifying answers, not realizing it was okay to stop 5 lines ago, and losing marks, making errors where there are no additional marks to be gained. I think that's right. You think actual maths is based on how well you can manipulate algebra. All actual maths. I appreciate the conviction. I like the sort of boldness of the statement. But having the experience of studying math 4 years in undergrad, many more years, 6 years, I think, in graduate school, what I can tell you is that there is so much more to math than just algebraic manipulation. Yeah, I understand. It feels like for you, it's been all algebra, and that makes sense. A lot of it has been algebra, let's be real. But the deeper you go in math, though that algebra never really like completely goes away, there's just so much more there. Yeah, no problem. I know what you meant. I respect it either way. If you're in Calc 1, putting in the extra hours now will make your next 3 years much easier. Totally agree. it's almost like a, it's a phenomenon that I've observed, that it's a pretty regular phenomenon that the grade that one gets in Calc 1, be it, I mean, if you're an A student in Calc 1, typically you got a pretty high likelihood of being an A student in Calc 2. But what I've noticed is that if you're a B, C, or D student in Calc 1, well, I guess if you're a D student, you probably shouldn't even be in Calc 2. But if you're a B or C student in Calc 1, in Calculus 2, you can expect a C or a D, respectively. Like, in other words, there's a letter grade drop that typically happens. First years of undergraduate courses are more centered on algebra. That could be the reason. Yeah, well, so I think a lot of the stuff that it's a very strange situation, right? Where a math major's perspective on mathematics is so radically different, I think, than most other people's perspective there, right? I think that that's really true. Just the view that they have about what math is and like what kinds of things they do on a daily basis. Like, you get far enough in math, like this kind of stuff that we're doing here, it's just not really what you do on a day-to-day, Not to say that this is bad or like not important. It's extremely important. But it's just different. It's just different. Oh yeah, so just to put a point on it, it feels like this isn't getting any nicer to me. I mean, I guess one thing that we could do is multiply the inside of this square root by 49 and then maybe pull out a 7 or something like that, if you know what I'm talking about. Then we'd have the square root of some integer coefficient polynomial, and maybe that's nice. But I'm going to be real here. I don't think anybody really knows what simplifying means. Not really. Like, to me, this feels simple enough. This line right here feels okay. I don't know. I'm okay with it. This feels kind of more complicated to me. What do you think? Like, there's no metric by which you can plug in. There's no, I don't think there's any algorithm that you could like plug in, in which you could plug in a mathematical expression and have it output for you the quote unquote simplest form or a simplified version of that. I don't believe that exists. Now, one could obviously make arbitrary rules up. One rule that I've heard in my life before, which I think is ridiculous, is never have a radical sign in the denominator. Like, this seems like there's, at least in American education, I know, like in grade school, there's a prohibition against putting a radical sign in the denominator. Isn't that dumb? I mean, what is wrong with 1 over square root of 2 exactly? It's an extremely useful number that comes up a lot. And it feels great to me. And yet, and you have like, lots of freshmen come into university and they're saying, like, you're not allowed to do that. What about you need to what is it called? Rationalize the denominator or de-radicalize the denominator? We need to de-radicalize the denominator here. Okay, people? De-radicalization. Thank you very much, YouTube, for the follow. But in reality, by practitioners, nobody cares. Nobody really cares about this. This is just fine, okay? In fact, this is preferred because you know why? Okay, I'm going to write this now I'm going to rationalize the denominator. Look how long it takes me and all this spilled ink. Look at so much wasted ink there. Instead of writing, well, is it wasted ink? I kind of think it is. Oh, no. You're thinking of sine of 45. This is the sine of 45 degrees, right? Am I right about that? Yeah. Or a sine of pi over 4 radians. Yeah. Well, it's good that you're connecting, making those connections. At least you can recognize it. Yeah. Yeah, so I don't know what simplifying means. So you say that Mathematica has a simplify function? Okay. What about the quadratic formula? Is that not what it does? So are you asking if the quadratic formula simplifies a quadratic? No. So what the quadratic formula does, so if you have a quadratic polynomial, ax squared plus bx plus c, there are sometimes values of x which makes this thing 0, right? Yeah, it solves for x if you set this thing equal to 0, the special number 0, right? If it's 0, then you can use this thing called the quadratic formula to figure out what values of x solve this equation. Yes. Those solutions are sometimes called roots or zeros of this polynomial. Yeah. As a devil's advocate, standardizing the representation of fractions makes answer quicker for the teachers. Yeah, that's true. And for example, so this has always been this has always been what I've imagined as the reason why there is a prohibition against expressions like this or representations like this, is that it does make it easier. It makes it easier to write multiple choice tests, for example, I guess, or something along those lines. Right? Instead of a student responding with something in a radical sign in the denominator, there's some standard, more or less standard way of representing the answer. 1 over square root 2 is so much nicer. I agree. Yeah, I mean, like, okay, try getting a quantum mechanic to like get off doing this sort of thing when they're talking about qubits, and you'll probably get a coffee mug thrown at you. And who can blame them, right? Can I explain Laplace transformations? In what context? Like, what class are you might be? What class might you be learning? Are you learning about Laplace transformations? Is it differential equations? What about having I in the denominator? I would say context depends. It depends. For that question, maybe it depends on context. But I don't. And I okay. Maybe I'll admit that maybe I would rather see it. I don't know what you would call it without having the I in the denominator, right? Because you can always, what is it? If you have like this, you can do the trick where you what is it? You multiply by the fancy version of 1, which is conjugate over conjugate or whatever. And this ends up being what? A squared, 1 over a squared plus b squared times a minus bi or something. Did I do that right? I do tend to prefer this. Like, that's something I can visualize, right? Much more as being in the complex plane. Oh, differential equations. So I can't quite remember the formula for it. We can look it up together. Not off the top, but the point of it is that transforms differential equations, which are typically hard to solve. It transforms them into algebraic equations, which are presumably easier. And then, so what you do is you have your differential equation, which is some statement about a quantity changing in time, and you transform it using the Laplace transform into an algebraic equation into some new variable, which you call typically S, if I recall correctly. And then you do stuff over in the S domain, and then you retranslate your equation back to the time domain that you're originally interested in. And there's lots of tools and stuff that you learn about to make using the Laplace transform like a pretty powerful weapon when trying to solve differential equations. Like if there's something more specific that you would like to know, like I'm happy to talk about it, I guess. I have taught this subject, so I probably have some resources that you might find useful. Let me see. Like if you can help me understand what it is you want to know, that'd be great. Like the point, what I explained, I think is the point of the Laplace transform for a differential equations class. Could you derive the formula for differentiation when you have the time? So do you mean that, like the definition of the derivative? I have one. I have one more question for you involving sine. Is that sine squared theta? Oh, so you want to solve this equation: sine squared theta minus cosine theta equals 0. So here's my hint for you. Do you know something called the Pythagorean identity? I think the double angle thing is not the way to go. I think instead you should use Pythagorean identity. Okay, so if you use the Pythagorean identity, you can rewrite this sine squared thinger. I mean, when to differentiate something, it is like f of x equals 2x squared becomes dy. So I presume you mean f prime of x equals 4x. Yeah, that's correct. So I guess I'm wondering how general you want this discussion to be. Like, do you want me to explain like where the definition of the derivative comes from? Yeah, in the USA we do. Well, I don't know. I feel like this is pretty universal, like this sort of thing. F prime. I mean, we also write this df dx. This is after good old Leibniz. Right, Karama. So what I suggest, so here's the Pythagorean identity. I'm going to get a fresh piece of paper. So you have sine squared theta, Am I writing this right? Sine squared theta minus cosine theta equals 0. I'm presuming this is what you want. And you want to solve this equation. So I'm suggesting that you should apply the Pythagorean identity, which is the most important trig identity that there is. It's not close. Sine. Oh, is it sine 2 theta? Oh, sine 2 theta? Like this? Oh, okay. That's less fun. But okay. So let's see. Sine 2 theta. I'm just working through my brain what the. So this is 2 sine theta cosine theta. Ugh. So yeah, what so the double angle formula I think that you're referring to is it is it 2 sine theta cosine theta or something? And then so then I guess I'm pretty sure this is right. I have to remember the angle addition formulas. A plus B. Is this called the double angle? I can never remember. There's a double angle formula and there's a half angle formula or whatever. But I think this is right. And I think this is very useful because what you can do then is rewrite this using this as sine 2 theta, sine 2 sine theta cosine theta minus cosine theta equals 0. And then factor out the cosine theta, right? So then either, when you have it in this factored form, you know that either this factor or that factor is 0. And presumably you know when cosine theta is 0. That should be more or less straightforward. And presumably you can also figure out when 2 sine theta minus 1 is 0. Hi, Exavention. It's going great. I did this derivation with a diagram of triangles on a circle. How am I doing on spinners? Honestly, I haven't even looked at it in the last week. I've been trying to do this streaming thing, so a lot of my free time has been taken up doing that. Still interested in pursuing it though. Yeah, some people have tossed some nice sets of notes that people have taken on that text, spin geometry, that I'm reading out of. So those are very helpful. But any real progress I can't say I've made, unfortunately. How are you doing? Spinners then twisters, huh? Okay. So Callum, I don't know how you feel about this, the calculus thing, but in general, when you take the derivative of something like x to the n, this is n times x to the n minus 1, as you probably know. And I'm wondering if you're asking me about the derivation of this fact or about the definition of the derivative in general, like the fact that f prime of x is equal to a limit as h goes to 0 of f of x plus h minus f of x over h. Like I'm curious which one you are curious about, I guess. Yeah, I need to learn spinners. I need to learn. Do I need to learn twisters if what I'm interested in is particle physics? I know exactly what you're talking about. You mean these trig identities? Yeah, e to the I a this one, this play, right? This is a great way of remembering those identities. See, on the one hand, this is cosine of A plus I sine B. And on the other hand, this is equal to e to the IA times e to the IB, which is equal to the product of cosine A plus I sine A times cosine B I sine. Oh shoot, and I messed up. This is A plus B up here. This is A plus B. I goofed up this line. Let me rewrite it. Sorry about the noise if you're hearing that. My the air purifier in my room is raging right now because I live in Northern California and right now we have wildfires going like crazy. The second largest wildfire in California is somewhat close by. I'm not worried about my safety or anything like that, but it is close by, and so it's spewing tons of smoke and ash. Now's a good time to stay inside. I have smoke and ash outside, and there's also that pandemic thing happening. So this is cosine of A plus B plus I sine of A plus B. And then what you can do is expand this out and compare the real parts, set equal the real parts and the imaginary parts. So cosine theta equals 0 at pi over 2 and 3 pi over 2. And any additional multiples, if like you can add arbitrary 2 pi's, right? That's right. But I remember I didn't read it very carefully, but you had bounds on the values of theta that you were considering. So 2020 seems very apocalyptic. I agree. It's strange. This is not normal. I've lived 42 years on this earth, and there's been more like serious disasters in this 1 year than all of them. All my previous years living here on Earth, at least in the United States. I don't want to speak for other countries. Other countries have it much worse. Theta is between 0 and pi. Yeah, so theta equal to pi over 2 is in there. So how would you get 2 sine theta minus 1 equals 0? So first solve for me sine theta. What is sine theta equal to then? Agreed. Exavention. It's important to keep things in perspective. As many criticisms as I might have about the United States, I'm glad to be living here. The first one. Okay, I'm getting sorry. I'm getting sidetracked. Callum, the first one. I understand the derivative is like a gradient. So this first one, do you know, like the way that it's typically done is initially it's proved for n integer. So do you know the binomial theorem? Is that what it's called? do I know it is maybe a better question. Do you know the binomial theorem, Callum? Which says that x plus y to the nth power is equal to the sum from k equals 0 up to n of n choose k, x to the k, y to the n minus k, or something like that. Okay, let me see. So if I multiply x plus y to the nth, like, I'm not proving the full binomial theorem, but I think I can show you just enough of it to make the derivation of this fact doable. So let's say we were to write out x plus y to the nth power like this. Just thinking here. Right. So will you agree with me that if I write out x plus y to the nth power like this is a product of n of these x plus y's, that the coefficient of the x to the nth power, so the way that we're going to get an x to the n is by taking this x and that x and all of these x's and multiplying them together to get an x to the n. And in fact, we'll only have one of them. You agree with that part? Now we'll also have terms involving not n x's, but n minus 1 x's, okay? And then the remaining slot being taken up by one of the y's. And how many ways can I get x to the n minus 1 times y? Like, what I'm asking here is what's the coefficient that goes right here? I'll be right back. Just give me 1 minute. My dog's a whiner. And maybe. No, exactly right. So the idea is that we can get, so the way that we're going to get terms of the form x to the n minus 1 times y out of this product is by choosing n minus 1 x's from these n of x's and choosing one of them to be a y, right? So in total, what we're going to get is n of these kinds of terms if we were to completely expand this thing out. Good. That's really good. And then everything else I want you to observe, and I'm just going to write this, and maybe you're not sure why I'm writing it like this, but everything else in this expansion will involve terms involving like y squared, y cubed, y to the fourth, etc. Right? Everything else in this expansion will have a power of y in it that's 2 or greater. Can we agree? So then what we can do, what we can do is apply the definition of derivative now. To f of x equals x to the n. And if we do that, I'm going to continue right here. So the definition of derivative, remember, oh, I wrote it here. Okay, of f of x is a limit as h goes to 0 of f of x plus h minus f of x divided by h. So now let's apply this to x to the n. So this is going, so apply to f of x equals x to the n. And what we get is the limit as h goes to 0 of, now what's f of x plus h if f is x to the n power? Well, that's going to be x plus h to the nth power, right? And then we subtract f of x. F of x is just x to the n, and we divide by h. Is that clear so far? And now, from the fact that we just talked about, here's the fact that I'm talking about, where we expanded out x plus y to the n, we can rewrite this term right here, right? We can rewrite this. And what it becomes is the limit as h goes to 0 of x to the n plus n times x to the n minus 1 power times y. Oh, sorry, not y. What's playing the role of y here is h. My bad. Plus terms involving like h squared, h cubed, etc. Right? Higher order terms than h is sometimes what it's called. How they're referred to. HOT and H, right? Higher order terms in H. So that's this whole thing right here is me using this version of this sort of truncated version of the binomial theorem to expand out this expression here. Then, of course, we can't forget we have a minus x to the n, and we also have a division by h. So now watch the sweet thing that happens. This x to the n and that x to the n kill each other, right? And then can you see that everything now, after we do that cancellation, everything in the numerator has a factor of h in it. For example, this term here clearly, evidently, has a factor of h in it. And because all of these terms in this parentheses thinger involve h squared, h cubed, etc., all those terms have a factor of h in them. So we can factor out that h and have it cancel with the h that's downstairs in the denominator. So in other words, what I'm trying to say is we can rewrite this as h times n times x to the n minus 1 plus, now instead of terms involving h squared and higher, it's going to be now h and higher. Oh, it's kind of confusing looking because my n's look like h's, but you'll just have to deal with that. Does this make sense, Callum? And now the h's kill each other. And we can ask what now happens as h goes to 0 to this remaining thing. Well, note, this term here doesn't involve h at all. There's no h here. On the other hand, inside this parentheses are only terms that involve h. So in the limit, these things are going to go to 0. So let me write that. So this thing here, as h goes to 0, these terms go to 0. And what we're left with in the end is n times x to the n minus 1 power. So in other words, we've shown that the derivative of x to the n is n times x to the n minus 1 power. Now the thing about this proof is that it only works when n is an integer, or a positive integer, right? So you have to be a little bit careful. It doesn't hold, this proof doesn't apply, rather, when n is, like, say, a real number, like square root of 2 or pi or whatever, which is not an integer, right? On the other hand, it is nonetheless true that the derivative of x to the n is this, even if n is not an integer. But I think you need at least like logarithms and stuff to get that done.